Hey, in these lecture videos, we'll be talking about properties of logarithms. This is section 6.5 from our textbook. In this first video, we're just going to talk about the inverse property of logarithms. And we'll start with an example. Suppose we want to evaluate the natural logarithm of e to the seventh. And remember that the natural logarithm is just log base e. So this would be log base e of e to the seventh. Now to evaluate this, we're going to first start by setting both sides equal, or setting ln of e to the seventh equal to y. So now we have two sides of an equation to work with. And then we're going to apply our definition of what the logarithm is. So the log of e to the seventh solves the equation of e to the y equals e to the 7. And looking at this equation, it's not too hard to see that if these two sides are going to be equal to each other, then we're going to have that y is 7. And this also follows from the fact that e to the x is 1 to 1. So we know there's only one solution for e to the y equals e to the seventh, and that solution is y equals 7. So therefore, ln of e to the 7 is simply just 7. All right, now we'll look at a second example that's in a little bit more generality. So it's the same setup, but now we have an arbitrary base for our logarithm and an arbitrary base for the number inside the parentheses. But again, we won't let this deter us. We'll use the exact same tricks that we used right above. We set this equal to y. And now we look at what we're solving. We have a to the y equals a squared. And therefore, y is just 2. It's the same logic over and over again. And now we're ready to write down what our inverse property is. So this is the first part of our inverse property of logarithms. It's that log of a to the r is just r. So when we're taking a logarithm with whose base is a of a number of an exponentiated number with base a, then we just get that exponent back. And this allows us to quickly solve a whole bunch of example problems. So if we had log 3 of 3 cubed, we can look at our inverse property and note that that's just 3. Log 5 of 5 to the 127. Again, the bases match, so we just get 127. Log of 3.14 of 3.14 to the 2.718 is just 2.718. So as long as the bases match, we can just pull out the exponent and that's it. All right, so this is part 1 of our inverse property. Now we're ready to start looking at part 2. Again, we'll look at another example, this time evaluating e to the natural log of 2.1. Wait, we'll start the same way as before. We'll just set that number equal to y. But now what we're going to do is apply the natural logarithm to both sides. The ln of e to the ln of 2.1 equals ln of y. Okay, but this is where things get interesting. With this, we have a log with base e, we have an exponent with base e, so we can use inverse property part 1 and reduce this down to just ln of 2.1, so that ln on the outside and the e cancel out and leave us with just that exponent of ln 2.1 equal to ln of y. And once again, we can kind of see that if these two are set equal to each other, then to make this equality happen, we would have to have that y is 2.1. And so there we have it. Now we've figured out that e to the ln of 2.1 is just 2.1. And hopefully this will give us an idea of what the inverse property is. And that will be that a to the log base a of y is just y. So the a and the log a cancel out with each other and leave us with just a y. Again, that'll give us some nice examples to work with. If we had 3 log 3 of 22, applying the inverse property part 2, we just get 22 out of that. If we have 5.7 to the log of 5.7 of 59, the 5.7, the log of 5.7 will just cancel with each other and leave us with 59. Or 1/2 to the log of 1/2 of 1/4 just comes out to being 1/4. And so those are the inverse properties that allow us to quickly simplify some of these expressions. All right, hopefully this video was informative. We'll have a few more in the series discussing the other log properties, but I'll save those for later videos.